Okay, so we're starting exponential functions, and these are going to be from multiple representations. So we're going to start with problem number 1. It says, the situation says that 3 years ago, Andy invested $5,000 in an account that earns 5% interest compounded annually. So I know that he's starting with $5,000, and I know that the interest rate is at 5%. Remember, we have to change the percent to a decimal. Okay? And they did that already for us. They already wrote down the equation. Now remember, this equation is like saying y equals 5,000 that he started with, parentheses 1 plus the interest rate to the power of t, which is x. Okay, is the same thing, but they added it already. So that's why they have 1.05. So what we're going to do is we're going to put that equation in y equals second graph. Y equals second graph because I need the table. Okay, and we're going to start from 0 years, 1, 2, and 3. All right, and I also know that it's going to be a growth because the middle number is bigger than 1, but we can see it on the table in a little bit. So let's put that equation in y equals second graph. We're going to put 5,000, no commas, 5,000 parentheses, 1.05 close parentheses. And we have to do the caret symbol. So this symbol right here, we're going to do to the power of x. So to the power of x. Second graph. And these are the numbers that we're going to write down. I want these. So go ahead and write them down on the table. And we're talking about money, so this 0.5 is 50 cents and this 0.1 is 10 cents. So don't forget about that. So in 0 years, he started with $5,000. 1 year later, he has $5,250. 2 years later, he has $5,512 with 50 cents. 3 years later, he has $5,788.10. Is this a growth or a decay? Are the numbers getting bigger or smaller? Okay? Bigger, bigger, bigger. It's a growth. So how much money does Andy have now? What does now mean? It says 3 years ago. So what does now mean? It means 3 years later. So at 3 years, how much does he have now? He has $5,788.10. How much money will Andy have in 10 years? So where am I going to go find 10 years? In second graph, right? We're here already. Go down to 10 years. This is how much money he'll have in 10 years. $8,144.50. So write it down. $8,144.50. Okay, so it's pretty easy if they give you the equation already. If they hadn't given you the equation, if they gave you the scenario, you can still go from the scenario to the equation. All they had to do was put what he started with and then add the 5 cents to that 1 because it's interest. He's earning it. Earning means that it's increasing. Okay? Problem number 2. Okay, so this one, they gave you the scenario and they also gave you the graph. Using the scenario, it says that Mr. Dudley purchased a car for $15,000. That's why it's starting at $15,000. And this is in thousands, okay? 15,000 That's how much he started with. So that's y equals 15,000, right? Parentheses. 1 plus or minus. It says depreciates. So that's going to be a minus. It's going down. So we're going to subtract, right? Actually, we're not going to start with the 1. It is subtracting. I mean, it's going down already, but it's already giving me the rate. So it's depreciating 85% each year. So 85% changed to a decimal is 0.85. So right here, we're going to put 0.85. Okay, and that number is smaller than 1. That's why it's going down to the power of x. That's the equation. You can put that equation in y equals second graph. Or you can pick pretty points from here. Right? Pretty points. There's not a lot of them. And then put them on the table. So if I put this in y equals second graph, that'll give me the table. So let's go put that equation in y equals second graph. And let's answer these. I know it's a decay. Look, it's coming down. So I can already answer that question. And then I can also answer this one. What was the initial value of the car? You can answer that one. You can answer all of these by yourself. And you can fill in the table by yourself. Put this equation in y equals second graph, fill in the table. I would pause right now, finish that problem, because I'm moving on to problem number 3. Okay, so problem number 3 says John has an ant farm with 100 ants. So he started with 100 ants. All of these equations start with 100 ants. The population of the ant farm will triple every month. Triple every month. That means times 3 every month. Which one of these says times 3 every month? That would be the answer. If you don't get it, then we're going to go straight from the story to the table. Okay, at 0 months, he has 100. 1 month later, you're going to times 3. So 100 times 3 is 300. And then second month, now we're going to do 300 times 3. I'm tripling it. That's 900. Okay, and then month 3, we're going to triple 900. 900 times 3 is 2,700. Okay, so really, which one of these equations gives you this table? You can put all of these in y equals second graph and see which one gives you this table. Or if you already figured it out, go ahead and put that equation in y equals second graph, because you're going to have to answer some other questions over here. Is this a growth or a decay? The numbers are getting bigger. It is a growth. Okay. How many ants will John have after 3 months? So go look at 3. How many would it be? And then how long will it take John to get more than 10,000 ants? So you're going to use the equation that you got, put it in y equals second graph, and go see when does he get more than 10,000 ants. Okay, more than 10,000 ants. All right, the next video is going to be for the problems on the back. I suggest you look at those because there's one question that I want you to not do. So make sure that you watch that video.